right. Welcome, Pre-Cal, to Sequences, Probability, and Counting Theory. Get this all framed up well. Okay. So there's a lot going on in this chapter, and we'll just jump straight in. So we have a bunch of sections that we're going to jump through. I'll try to get through two today. Sequences and notations and arithmetic sequences. So they go quite quick, and 11.1's not too bad, but it just has some tricky stuff in it. So I'll just jump straight in. Sequences and notations. We've done a bit of this before. They define a sequence. We know what a sequence is, right? There's some kind of change. There's two types of sequences you can see. So get ready for that. You would see either of those in this type. Let's see, they don't get into any of this yet. They break those different types down up here. So we have arithmetic and geometric sequences. We've studied both in Algebra 1 and Algebra 2, and so now they're just reviewing this very quickly here. So let's just jump straight in. Everyone knows all these words, you know, the first term, second term. So this is how they notate these things. A to the nth term, which means kind of like the general term is 2 to the n. So this represents all possible terms in a sequence, right? So this is kind of like the abstract idea of all of a sequence. And this is a to the 31st means the 31st term, right, in that sequence. Right, so same thing, a bunch of graphs. We'll move through this quickly. Okay, a sequence is a function whose domain is a set of positive integers. A finite sequence is a sequence whose domain consists of only the first n positive integers. Okay, so the numbers in a sequence are called terms. A variable a without term subscript is to represent the terms. Okay, the term is called the nth term. So technically the last term is called the nth term, but that's okay. It could be any term in the sequence is called the nth term, or the general term in the sequence. The explicit formula defines the nth term of the sequence by using the position of that term. Okay. So let's play around with some of these ideas just real fast. So first up, example 1. They say, write the first 5 terms of the sequence as defined by the explicit formula. Let me scoot this guy over. Let's do this. Just a touch smaller, and we're good to go. Okay, here's some instructions in case you want to watch that. And of course, you should follow along with me in your own book. Okay, so here we go. So it says, write the first 5 terms in this sequence. So a of n, I won't do all of this, but I'll just do a few, equals negative 3n plus 8. Okay, so what would be the first term? Well, we would substitute 1 in here. So we'd say a of 1, or the first term, would be negative 3 times 1 plus 8, which comes out to what? Negative 3 plus 8 is 5. Cool, that's it. What would a2 be? So that would be negative 3 times 2 plus 8. Okay, so notice in the explicit formula, what we're doing is we're just inputting in whatever term they want, right? So we get a negative 6 here, so we get a 2, and then etc. So what we're doing here is we are calling out a destination, right? So we're saying we want the nth term. We want whatever term, the first, second, third term, and then we get the value for that. So notice that it's not recursive, which we'll learn about in just a little bit, where we actually piggyback from one term to the next, but this is very like specific destination. We're saying we want that term. We want the third term in the sequence. So then you have to manually go through and do it each time to figure out where it is to map out the changes. And so there you go. There's all the answers mapped out there. You can graph them, of course, and check that out. Okay, so it says write the first 5 terms of this sequence. Same thing. They just make it a little bit more complicated now. Let me scooch this over and make this a little bigger. So here's this term, of course. So what would we do here? What if we said this is running out. Okay, hold on a second. What if we say some a to the first power would be what? So of course we have a negative 1 to the first power, and then 1 squared over 1 plus 1. So this looks confusing, but it's really not bad. So of course we get a negative here. So we get the negative, that stays. If it's squared or any even power, it would be positive. But any negative, or not negative, but any odd power would give you the negative, or the negative would remain. So this is like negative 1 over 2. Boom. That's it, etc. You just put in each of these values, solve for it. Super duper straightforward. Okay, almost too easy. We'll get into harder stuff here in just 2 seconds. Example 3. So it says write the first 6 terms of the sequence. This one's a lot harder, so let me take this and go slowly. So it says, now, they've kind of pieced this out, right? A piece function, a piecewise function. So let's go slowly and see how to play this game real fast. So let's say a of 1, right? So now we're going to have to pick which directions we want to use. And it says if, which is conditional, n is not divisible by 3. So in this case, n is 1. So then is 1 not divisible by 3, or n is divisible by 3? So 1 is not divisible by 3. So we need to say n squared. So that's going to be 1 squared 1. Done. So how about a to the second power? Also not divisible by 3, right? So that would be 2 squared 4. And a to the third power is obviously 3, right? But now this is confusing because they say if it's divisible by 3, which it is clearly, we need to use the other formula, right? So we need to use this one now. So we need to say 3 over 3, which is actually 1. Okay, so this is just a way that they can make you explicitly follow a set of directions. It's really not bad. And onward, right? You can just keep going and follow those directions. And it should give you some interesting outputs. Notice this first 2 nodes are the first equation. The third term is the second equation. And then again, right, this is the squared equation, and this is the second one. Okay. Finding explicit formula. Now, this is the thing I find to be the hardest, and you will have to slow down and really take your time on. And it really bogs me down. So let's take a look at these. I'll just zoom in and not try to give away the answers. Okay. So let's look at this first one, right? So we're going to try to say an explicit formula for the nth term. So that's like a of n, right? So that means just the total abstract idea here. Clearly it goes negative, positive, negative, positive, negative. So we're going to start with the negative, right? So we're going to say negative 1, right? And because it comes out, so that first term will be to the nth power. Cool. Does that make sense? The first term will give us the first negative, and then the second power will give us the positive. Okay. So we have this properly alternating between positive and negative outputs. Now, how is the numerator changing? It's going from 2 to 3 to 4 to 5 to 6. How could we possibly write that out? Well, to get a 2, to get the first term, we'd have to say n plus 1, wouldn't we? Wouldn't that give us 2? And the second term would give us 3. Okay, good. So it looks like our numerator's all sorted out. Now, how is the denominator changing? So notice that it starts at 11. So now how could we possibly write a numerator, or a denominator, excuse me, that would start at 11? So, and we need it to change by how much? How is the denominator changing here? So it's changing by what? 2, right? So we need some 2n, right? So that means that change is 2. Every term will increase by 2. And so then once we have that, what do we have left over? If we put a 1 in here, we have 2. And 2 plus what would give us 11? 9. And there you go. There's our equation all worked out for you. So let's plug in 1 and just test it really fast. So a of 1 is, of course, negative 1 times 2 over 11. Negative 2 11ths. We did it. All right, cool. And obviously, check the next term, because sometimes you make some assumptions that are not always correct, and they don't work out. But in this case, we know we're correct because we have a nice answer to confirm our thoughts. But when you're on your own, obviously double check all over the place. How about this next one? So exact same theory again, a of n, we have a negative term, so negative 1 to the nth. But notice it stays negative, right? So then that's not really alternating, is it? So it's just negative 1 out front. Cool. And then the numerator stays the same. So we don't even need to say that. Negative 1 times 2. We could just say, what? Negative 2? Why not? Right? Because that's not changing all the way across. But what is changing? The denominator. So how is it changing? It is what? 25, 125, 625. That's some dramatic change. So this is probably 5 squared. This is 5 cubed. 5 to the 4th power. So how can we write that out in a general form? We would say 5, right? And